Hi, I'm Alex Lawrence Barkley of Sense Media here at the inaugural AutoSens conference and exhibition. I'm here with Andrew Turner from NXP. You've come to the show with one main system which is called Blue Box, is that right?
That's correct. Blue Box is NXP's autonomous drive development platform. So the purpose of the Blue Box is to help ADAS development on one platform. So what we have is a high performance compute platform with low power consumption and a portable platform with automotive levels of reliability and safety.
Right, so essentially you're talking about a graphics compute platform to take multiple inputs from various different sensors?
Yeah, so what we have is a combination of NXP's high performance ADAS microcontroller with vision accelerators on it. We have that in conjunction with a high performance network processor within the one box. So the high performance network processor consists of 8 ARM E72 cores running at 2 GHz with up to 64 gigabytes of RAM and a large SSD disk in there. So that shares the information with the ADAS microcontroller via PCIe. So the idea or the concept is that you can develop your ADAS algorithms and the ADAS technology on the microcontroller and store all the data produced from that on the high performance compute and develop other technologies using the high performance compute. It runs vanilla Linux, so you can use open source code. You can do anything you can do in Linux, you can do on the Blue Box.
So it's a fantastic development platform, very flexible, and it seems from the live demo running in the background here quite powerful as well.
Sure.
We've got just behind me, we've got a 3D printed bus, is that right?
Yeah, sure. So this is a 3D printed bus printed by one of our partners, Local Motors. So it's an Ollie bus. They are working with us with the Blue Box to help in their development. So to help us demonstrate our technology, they 3D printed us this little miniature Ollie bus for us to use as a platform for the Blue Box. So we've kitted it out with the Blue Box and a bunch of associated ADAS sensors. So we have surround view cameras, we have front view pedestrian detection, we have NXP 77 gigahertz radar sensor attached to it, and we have a LiDAR on top.
Right, and what sort of percentage of those are actually NXP products, or are they all off the shelf?
The radar is NXP's products, both the microcontroller and the analog front end. The cameras are NXP don't make cameras, so they're off-the-shelf serial cameras. The LiDAR is from Quanergy, who are also a partner of ours, so we're using that. All of the information from all the sensors though, is being fed directly into the Blue Box and is being processed by the Blue Box.
And with off-the-shelf components, how long did it take you to integrate those into this single system? How long did it take you to build this prototype?
To build this prototype took us and the software team less than a week. We have standard automotive ports on the Blue Box itself. We have 8 gigabit Ethernet ports, so it's almost a plug-and-play solution. You have to develop some of your own software, but it's a standard configuration. Can
we just talk through the screens here? So on the right-hand side there, we've got a video feed being fed out. What are those yellow boxes indicating?
The yellow boxes are detected by the cameras. On the right-hand side, we also have the feedback from the radar sensor. So if someone's close enough, they'll trigger the radar sensor. The combination of the data from the camera and the radar trigger the car to drive slower or stop or go faster.
Right, so I should also emphasize that that's just using a video feed from one of the several cameras that is on board the camera. Now, on the middle screen there, we've got something that's looking a little bit more immersive, almost a 360-degree view. Tell us about that.
Okay, so this is a demonstration of surround view. So we're using the S32 V234 part of the Blue Box. That's the high performance ADAS microcontroller to take the feed from the 4 cameras and produce a synthetic surround view image. So we have it set to one particular view here that we thought suited the floor, but you can actually take the image and drag it about and position yourself anywhere within the virtual room that you've created. Okay, so at the screen on the left-hand side, we can see lots and lots of coloured blocks, as well as lots and lots of little spotty clouds. Can you just talk us through, what are the coloured blocks, first of all? So the coloured blocks are people in the conference floor here, or if you were using this an autonomous vehicle, it would be pedestrians. So what's actually happening is this is the LiDAR that's mounted on top of the bus. So it's a security demo that's being processed on the S32V microcontroller, and what's happening is that you can see that each person's been picked up and tracked, and the the S32V device does the classification of the objects and considers whether they're a person or not. And once it considers that they're a person, it recreates them in a block. Okay, so you can see the different colours of the red, yellow and green characters as well. So you can see that represents how far away they are from the vehicle. So obviously you could, if they were red, you could take evasive action, perform a braking manoeuvre. If they're yellow, the ADAS system might start thinking about what might happen next.
Andrew, just to wrap up, thank you for showing us all of the technology, and we hope you enjoyed the rest of the conference and exhibition.
Okay, thanks very much, Alex. It's been a pleasure to be here, and we look forward to working with you again in future.